Good morning, algebra students. Happy Tuesday. Same thing as usual. Flipgrid is there if you'd like to answer. You've already found the YouTube lesson, and you should pause this video and try this example in your notes. Check your solution. I'm gonna show you how to do that, if I didn't show you yesterday. Okay, so pause, try it, and then unpause it, and we will do it together. So, to solve this equation, remember we use the zero product property from yesterday, which tells me that this or this is equal to 0. So, what I'm going to do is I'm going to take 3s plus 5 equals 0, or 5s plus 8 equals 0. So those are my two options. Now I just get to solve both equations and see what works. So I'm gonna start over here by getting this s by itself, minus 5 from both sides, and we get 3s is equal to negative 5. Divide both sides by 3, and you get that s is equal to negative 5 over 3. Beautiful. Beautiful, beautiful. Okay, I will show you how to check your answer at the end, but for now, let's move on to this guy. To solve for s, I need to subtract 8 on both sides. That gets rid of this. Now I'm left with 5s equals negative 8. So to get this by itself, I need to divide both sides by 5, which gives me that s, oh my goodness, is equal to negative 8 over 5. Now to check your answer, what that means is if I put this in here, if I put that in this equation for s, will I actually get 0? So let's try it. 3 times negative 5/3 plus 5 equals 0. Is that true? Well, let's see. 3 times negative 5/3. These 3's just cancel each other out. And I get negative 5 plus 5 equals 0. Yeah. That checks out. That makes sense. And if we wanted to check our solution over here, we would do the exact same thing. We would take this, we'd plug it back in here, and does it actually make this equation 0 or not? If it does, awesome, we were right. If it doesn't, we did something wrong and we should check our work. Okay, all right, now on to what we have for today. So today, too far. Our learning target is, I know what a polynomial in factored form is, so that is very similar to yesterday, and our success criteria is I can solve polynomials by putting them in factored form. So this is what's new for today, is we need to be able to put polynomials in factored form, because if they don't appear to us like this, in this factored form right here, if they don't appear to us like that, then we gotta make them look like that in order to solve them. So, by the end of today, you will be able to solve polynomials by putting them in factored form. And if you want to do social contract word of the day, go for it. I probably should have taken that piece, taken it out, but that's okay. All right. So this is just a review from yesterday. This should be in your notes. The zero product property. If I multiply two numbers together, then one of them, at least one of them, is 0. A new vocab word for today is greatest common factor. So, what this is, the greatest common factor, it is the biggest number that is a factor of 2 or more other numbers. So, this is an example over here. This right here is an example of them finding the greatest common factor of 12 and 16. GCF means greatest common factor. Greatest common factor. That's what GCF stands for. So over here, they're finding the biggest number that goes into both 12 and 16. So you can see here, right here, they listed out all the factors of 12 and all the factors of 16. And then they just found which one was biggest. So 12 didn't work, 16 didn't work, 8 doesn't work, 6 doesn't work. But hey, look at that. They both have a 4 in them. And because 4 is the biggest number that goes into both 12 and 16, we call it the greatest common factor. Fantastic. This is going to be necessary for what we do today. So let's jump right into the first example. We are factoring out the greatest common monomial factor from 4x to the 4th plus 24x cubed. So remember, first, let's review what is a monomial. A monomial is a polynomial with one term. So this could look something like 2x. It could look like 5. It could look like 3x squared. It can look like a whole bunch of different things. So what we want to know is what is the biggest thing, the biggest term, biggest number, biggest variable that goes into this and this. Well, let's see. I see a 4 here. So 4 goes into this and 4 goes into this, right? 4 goes into 24 because 4 times 6 is 24. So the 4 is good. Let's use the 4. Next thing I'm noticing is I have x cubed and x to the 4th. So in both of these things, this one has an x cubed. Remember, x to the 4th is just x cubed with another x. It's just 4 x's instead of 3 of them. So there's also an x cubed hiding in this x to the 4th right here. Because there's 4 x's, so there's 3 of them. There's also another one. There's 4 of them, but inside of 4, there is 3. If that makes sense. So both of these things have an x cubed in them. This one just has one more. It has x cubed and then 1, but they both have x cubed in them. Beautiful. So this right here is our greatest common monomial factor because 4 goes into both of these terms and x cubed goes into both of these terms. So let me show you why this is important. Let me show you why this matters. We're going to rewrite this 4x to the 4th plus 24x cubed. So if I know what factor goes into both of these things, I can factor one of them out. That's what we say when. So I'm going to take my 4x cubed. I'm going to take this and I'm going to bring it over here. Now, remember our distributive property? Our distributive property that said when I have this, when I have 2x plus 5, I just put the 2 in there and I get 2x plus 10. Hopefully you remember that. What we are doing is we're doing the opposite of the distributive property. We're actually taking this 2 and we're pulling it back out. So what we want to do is we want to go from here to here. We want to go from this form into factored form. That's what we're trying to do. Because when I'm in factored form, when I'm in this form, I can easily solve. If I have equals 0, I know, 2 things times 0. When I have 2 things multiplied together equal to 0, one of those things has to be equal to 0. So I'm trying to find the common factor that I can pull out to put it in factored form. So that's what I'm doing here. I have this term that I'm pulling out so that I can put it in factored form. So what we're going to do is if I take this factor and I pull it out of this, what am I left with? Well, if I pull out a 4, that 4 is going to go away. So I won't have the 4 because it's going to go away. And I'm pulling out 3 x's. If I have 4 x's and I'm pulling out 3 of them, I'm just left with one x. If that doesn't make sense, don't worry, we'll talk about it some more. Now what I'm going to do is I'm going to look at this term, and I'm going to pull a 4x cubed out of this term right here. If I pull a 4 out of 24, what am I left with? 24 divided by 4 is 6. Beautiful. Fantastic. And if I pull an x cubed out of x cubed, well, then there are no more x cubed. So that's it. That's it. This here is our final answer. And I know what you're thinking, Mrs. Dodge. That was weird, and you went fast. And I think most of you are probably at a thumbs sideways right here. Wow, talking too early in the morning. You're either at a thumbs sideways or at a thumbs almost up, but not quite. If your thumb is up, awesome, good for you. But I think I may have talked about this a little bit fast, so let's talk about it again. Here's how we can check to make sure that we're right. If I do my distributive property and put this 4x cubed back in to this thing right here, I should end up with what I started with. I should end with what I started with. So, let's do that. 4x cubed times x. Well, 4x cubed times x. That's just 4x to the 4th, right? Because this has a little imaginary 1 there. And then when I'm multiplying with the same base, I add the exponents. Cool. So I get 4x to the 4th. And look at that. That is the same as what I started with. So that feels good. And next, if I do 4x cubed times 6, remember I just multiply the normal numbers together. So that is 24. And then the x cubed comes along for the ride. And wow, would you look at that? That's exactly what we started with. So I wrote check. I wrote check right here because this is how we check our answer. Once we get it in factored form, this is how I'm checking my answer to make sure that I'm correct. Awesome, awesome, awesome. Okay, so let's summarize. We found the greatest common monomial factor, which was this 4x cubed right here. And then we just pulled it out. We just pulled it out of the other factors. We did this over here. We did the opposite of the distributive property. Pull some things out. And that is what helped us get this into factored form here. Okay. We are going to do another example where we do this again. But I'm going to show you why. We're gonna put it in factored form and then we're going to solve it. So, oh yep, we can check, and we most certainly did indeed get it right. Fantastic. So now our next example is to solve by factoring. This is why it was so important that we put it in factored form, because once we have it in factored form, it makes it very easy to solve. So, let's start with this one over here, shall we? I need the biggest thing that goes into both 2x squared and 8x. Well, let's see, this one has a 2. And hey, 2 also goes into 8, so that's good. So I know 2 goes into both of these things. And now let's look right here at the x's. This one has an x, and this one has 2 x's, but they both have at least one x in them. Okay, so they both have a 2, and they both have an x. So 2x is going to be my greatest common factor here. Beautiful. So let's do that. Let's pull out a 2x. And if I pull a 2x out of here, I'm just left. So I take the 2 away, I pull the 2 out. And then if I take an x away, I'm just going to be left with x. Awesome, awesome, awesome. So now let's look at this term. If I pull a 2 out, 8 divided by 2 is 4. So I'll be left with 4. And if I pull an x out, well, that x just goes away. And now I'm just left with 2x times x plus 4. Wonderful. Equals 0. Don't forget that. It says it over there. We also have to bring it down here as well. So 2x times x plus 4 equals 0. Awesome. And you remember from yesterday how to solve this. We get 2x equals 0 or x plus 4 equals 0. So, to solve this one on the left right here, the one that my head keeps covering up, I just divide by 2 on both sides, and we get x equals 0. And over here on the right, I just need to subtract 4 on both sides, and x is -4. Beautiful, -4. Awesome, awesome, awesome. If that went too fast, don't worry, we're going to do another one. We are going to take a look at B over here. So, first thing I'm going to do is, I don't have this equal to 0. I want this equal to 0, but it's not. So let's make it. Let's make it equal to 0 by subtracting 15n from both sides. Now, I get 6n squared minus 15n equals 0. There. That's not so bad. I like that. Okay. Next, I want something that goes into both of these. The biggest thing that goes into both 6n squared and -15n. Well, let's see, 6, if I look at the 6 does not go into 15. So that's not going to work. Let's see, what are some factors of 6? 2. 2 times 3 is 6, so 2 and 3 are both factors. 2 goes into 6. 2 does not go into 15. 15's an odd number. But 3! 3! 3 goes into 6, and 3 goes into -15. Okay, nice, nice. So the 3 works. And then let's see, as far as n's go, this has 1n, and this has 2 n's, but they both still have at least 1 n in them. So 3n is going to be our biggest term that we can factor out here. Wonderful. So when we do that, when we factor out the 3n, we are going to be left with, let's see, 6. 6 divided by 3 is 2, and n squared divided by n is n. So you can see that these two together make 6n squared. And that's what we're trying to do here. We're trying to split up 6n squared with our greatest common factor here. Okay. And now we're going to pull the 3n out of the -15n here. So -15 divided by 3 is -5, and n divided by n is 1. It just goes away. Perfect. Awesome. And don't forget your equal 0 comes on down, always. If you have an equation, you can't just get rid of the equal sign and make it an expression. That's not how math works. Okay, and now look at that. Beautiful. We have it in factored form. So now we know that we have either 3n equals 0, or we have 2n minus 5 equals 0. Both of those things, either one of those things could be true. So let's rewrite this where we have more space. If 3n equals 0, I would divide by 3 on both sides, and I would get that n equals 0. Beautiful. And let's rewrite this where we can see it. 2n minus 5 equals 0. Alright, we're rewriting so we have more space. To get the n by itself, I need to add 5 on both sides. Get rid of that. And then 2n equals 5. So I need to divide by 2 on both sides, which gives us n equal to 5 over 2. That's a little cramped, but I think you can still see it. Awesome. Awesome, awesome. So the main thing you want to remember how to do today is pulling out this greatest common factor here. That is the main thing that you want to be able to do. Awesome. Wonderful. Okay, and we can check to make sure that we were right. X equals 0 and x equals -4. And n equals 0 and n equals 5 over 2. Perfect. We were correct. Alright. So, okay, questions. Questions. Remember that if you have questions, you're already watching the YouTube lesson if you're here, so good for you. Or tune in to Mrs. Dodge's live stream from 12 to 2 every weekday, Monday through Friday. We will be here live streaming from 12 to 2 to answer your questions. So, those are your options. Watching YouTube lesson, you can rewatch it, you can email me, you can tune into the live stream. Whatever you need, I am more than happy to help you with. Here is the classwork, homework, you know. If you want to do it now for homework and get ahead, hey, do it. Absolutely can do it. But this is also what we will do eventually when we come back to school. All right, and last thing I have for you today is your launch. And it reads, when you recover or discover something that nourishes your soul and brings joy, care enough about yourself to make room for it in your life. There was a lot there, so let's unpack that. When you recover or discover, when you find something that nourishes your soul, that gives you life and gives you passion, care enough about yourself to make room for it in your life. So make room for the things that bring you joy, because that shows that you care about yourself. If you don't care about yourself, you won't care about the things that bring you joy, or the things that that maybe you need to recuperate. So care enough about yourself to do things that bring you joy. Take a break, like do all your homework, of course, do all your homework, but also relax and do things that nourish your soul. For me, writing essays day after day after day would not nourish my soul. So I would, if I were to do that, because I wrote a lot of essays in college, but I also needed to do things like math and theater and sing and things that nourished my soul so that I didn't get so burnt out on papers, have to write papers. Yes. So, wise words from Jean Shinoda Bolin. Probably mispronounced that. But yes, that is your launch for today. Take it with you as you go throughout your day. And if I don't see you on the YouTube live stream later, have a great day. Bye.